Hi guys, I'm going to introduce you to a new piece of software that you may not have used before, a tool called Autopsy, which is a free open source public tool that was originally developed to facilitate police investigations of digital evidence. It's not quite perfect, but it does fit into the computing security toolkit, because one of the things that allows you to do is to examine disk systems and look for what's been happening on them. So that might be something you would want to do if you were looking at, for example, a computer that was attacked and penetrated, and how that led to different sorts of activity. You'd be able to see finds of traces of files and different sorts of activity taking place on it. And so it's relevant to this sort of thing. But I'm actually going to give you a scenario that I wrote a long time ago, which is to do with a criminal investigation which might have some implications of terrorism involved. And you can have a discovery of the evidence by looking at the original source disk and work out what might have been going on. It doesn't take very long to do, in fact, but I think you might find it interesting and quite fun. So first of all, what I'm going to do is show you this, which is a file, is basically the scenario. And the scenario is that a person was detained by the Hampshire police as part of an investigation into an alleged criminal activity relating to animal experimentation taking place in a remote and fictional campus that existed in the UK. And this is to investigate a man called John Smith, who worked as a research technician, and he was basically looking at things like brain scans and things like this. So he was involved in what we would call vivisection, that is dissection of living animals, effectively. So it's not pleasant, and a lot of people find it very morally objectionable. There was a fight, and there was some apparently over some piece of some storage device, and nobody involved in that activity claimed ownership of that. He claimed that it had nothing to do with him. Later on, he said maybe he took it from a student. It was an old disk that the student had handed in as part of an assessment. You've been asked by the senior investigating officer, which is a term usually used for the senior police officer involved in an investigation, so probably an inspector or a senior inspector, to actually investigate the case and see if you can find any evidence of anything strange going on. Now, there are two pieces of law that are relevant to this. One is the Police and Criminal Evidence Act, 1984. So this is UK law, by the way. So you have to make sure that the thing you're asked to examine, you have a right to examine. Was it seized by the police correctly and legally? So in the UK, we have Section 19, which covers general power of seizure. So these are, for example, it has two subsections, subsection 2, subsection 3 and 4. So a constable may seize anything which is on the premises if he has reasonable grounds for believing it's basically been involved in an offence, and he may seize anything if he has reasonable grounds that it may be evidence relating to an offence that he's investigating. And that can include things that are in an electronic form and which can possibly be removed from the scene if they are left there. So you can read the full legal wording of the section there. Now, the other thing that's possibly involved in this is the Terrorism Act. So we've got the Terrorism Act 2000, Part 6, Terrorist Offences, Section 54, Weapons Training. A person commits an offence if he provides instruction or training in the making or use of firearms or radioactive material or weapons designed or adapted for the discharge of any radioactive material, explosives or chemical, biological or nuclear weapons. A person guilty of an offence under this section can be liable for, on conviction, to imprisonment for life, to a fine, or to both, or on summary conviction, to imprisonment for a term not exceeding 6 months, to a fine, or not exceeding the statutory maximum, or to both. So that's basically one part of the background. Now, the other thing that you've got is this examination cover sheet. Now, this is a standard document that is used by law enforcement in around the world, really, and basically it's the document that is passed by the police investigation team to the forensics investigator, and it basically tells them what they're trying to find out. So don't worry too much about the dates. They're very, very odd and inconsistent. So we have two police officers, Holmes and Watson. They seized it. They say they seized it under the PACE, Police and Criminal Evidence Act, Section 18 and 19, from this location at the RMIT campus. The suspect was called John Smith. And it's a mobile digital storage device in his possession. There's a series of pieces of information. So it's a USB stick. So please examine for evidence of any association with terrorist activities or groups. Report in writing as soon as possible in order to assist in the investigation of the suspect. Now, the Terrorism Act allows you to hold people for a period of time. A part of our law actually defines how long you can actually hold somebody whilst you're doing an investigation, so you can't hold them indefinitely. And so he's got to be released within the time limit. So the clock is counting, and we want you to find something as quickly as possible so that we can actually do that. We don't know if it's going to court yet, so we don't know the date of the hearing. And then you put in there your name effectively. So this is an image that was seized, and they used MD5 sum hash, and this is the MD5 sum hash of that device. Now that's the two pieces of information you need to be able to go to the next stage, and the next stage will be actually looking at the evidence using some software. Now I'm just going to bring up that software screen and make sure you can see it in a moment. Yes, there we go. So now you can actually see the it's just gone to leave that machine. I've been leaving it for a while. You can actually see the computer I'm going to ask you to use to actually do this investigation. So this is actually a very low power Intel stick. It's the only PC I have, and it's sort of not exactly overloaded with capacity. However, it's good enough for this tool. So we're going to use a tool called autopsy. So I will just start that up. And you'll see what it's like. Sorry, there's a bit of a delay as well because I'm running it in an external, so a VLC sharer. So guys, this is what autopsy looks like, and we're going to create a new case. Takes a little while to respond. We'll call the case John, RMIT. And it's going to ask us some questions as we set it up. So case number 01. The investigator is going to be Dr. John, and no particular notes there. So we finish that, and then we go on to the next case. So it's going to create this case file now. And basically what a case file does is it holds notes that you make, files that you make. You can extract things into it from the evidence items to actually give some information about what's going on. It's going to ask us a series of questions about particular tools that it's going to use to load into its file, some of which won't work, so I'll cut them off beforehand. But I'll give you an idea about the sort of range of things it can do. Just take it a little while to respond on this system. So we're just going to call it John 1, and we'll go to the next. We're going to load a disk image file. So a disk image file is an image that you make of an original storage device. It's called an image file because what you're actually doing is copying all the locations that the file can actually hold. So every area where there can be storage is actually copied into this file. So you end up with a file, for example, you have say an 8 gigabyte USB stick, you'll end up with an 8 gigabyte file. So it's identical in terms of content. And you can check that it's identical because you can do a hash of the original and hash of the destination file, and they should be identical because there should be no difference in the data. But you can do other things. You can look at local disks, for example. So you could boot this into a system, connect it up to another hard drive you wanted to examine and use that to examine it. You can use it with logical file systems as well. You can use it to look at unallocated space. Now, usually when you partition a hard drive, you will not necessarily use every possible space within the hard drive. So you'll have some areas that haven't been used, and these are unallocated space. And the reason why they're interesting is because they're sometimes used to hide stuff. So you can actually find things in there. You can use an autopsy logical image files, and XRY is a forensics tool used for examining mobile devices. It's one I have some experience with, and I actually am a trainer in XRY. Unfortunately, I don't have it at the moment in this place, so I can't actually show you how it works. But I might have some old files from somewhere, or I might be able to get some colleagues to download them to me. So XRY allows you to look at a wide range of different types of mobile device, iOS, Android, whatever. So we're going to do everything else and leave it basically to its default settings, and should be okay. Now I need to add in the file itself, and I'm just going to have a look. And here I have the image file, happens to be in the directory that I last opened, so that's very convenient. And it's not a massive file; it's only just over 1 megabyte in size. It was originally made by me back in 2008 as is one of the first cases or simulations of digital evidence I created, but I still quite like it. It's quite cute, so I hope you will enjoy it as well. So let's see if we can get that to go. Next. Now we're going to turn off a few things in here. The Android analyzer, for example, won't work properly on this system at the moment, and the iOS analyzer neither. And if we look up here, I think we've got another one that I may want to turn off. Most of the rest will work. As you can see, you can look up for a variety of different sorts of things: picture analyzers, embedded file extractors, extension mismatch detectors. So for example, somebody has some nasty photographs and they've called them docs or something like this to try and hide them. Well, this system can sort of identify that there are mismatches in the file type. Photo recover carver, so you can actually recover deleted partial files. So often when you delete a file will be stored in a lot of different sectors. Some of those may be overwritten, but you may still be able to recover all or part of the file. So those things are good. Virtual machine files, DJI drone analyzer, that's quite interesting. So you can analyze the data from a DJI drone, which includes, for example, flight data, flight path, etc. And of course, you'll have things like video and things like this from the external SD cards. I have some sets of data for that available. They actually come from a public resource on forensics data, but I will probably not be able to show them to you because they're gigabytes in size. Okay, so we'll go on to the next bit and let's see how many error messages it generates. Yeah, I know it's going to generate some. So Android Analyzer, etc. won't work. We should be able to get it to start up, and it'll take it a few seconds to work itself out, and then there we go. And so we've got this table here. So we can actually open this disk in much the same way that we can open anything else. And we can see this view of it, which is a view that is in a hex table. So you can see things like, for example, look, there's some data that's actually coming from the header file of the file system. So it's telling you it's an MS-DOS file. It's actually an ancient FAT12 format, which isn't usually loadable in many systems now. Otherwise, I could actually load it as an image and let you see its contents. And you can see there's a lot of bits and pieces of data inside there. Even though it's only 1 megabyte, there's actually loads and loads of files. But notice one thing, all the ones with an X on are the ones that are deleted. Okay, so let's have a look at some of the analysis. Well, we can look at the file types. So we can look at the file types by extension, and we can see that there are 4 image files. We may even be able to, there we go, we can see them there. We can look at the documents, and we can see that there is 1 Office document file. So this is this one called mum.doc. There are 2 PDFs, and are there any executables? Let's have a look. No, there are no executables. And if we wanted to, we could just look at the deleted files themselves, and so we can see in the system that there are in fact 7 deleted files. Now the file viewer does allow us to actually have a look at the contents of files. So we can, for example, click on something like this one, and we can see that this is some sort of XML file. It actually seems to contain some URLs, etc., link to BBC website, etc., things like this. And this one, for example, is a JPEG. So again, the built-in file viewer will give us a view of that document as well. So we could have a look through and see what we can find out from that. Now, another thing that's quite useful is we can look at the timeline. So let me generate the timeline. Now, this doesn't work on some systems, but it works, I think, on this one. Takes a little while to do it, and then it's generating a timeline, and you'll be able to see the date in which when I made this, which is nearly, let's see, about 14 years ago. Now let's see if we've got something back here. Yes, so back in November 2008, this is when I actually made this disk. I originally made it as a floppy disk, actually, and I just duplicated lots of copies and gave it to the students to analyze back in the days when computers actually had floppy disk drives. So there's quite a lot of activity then, and then in fact there is something right at the end, I think. Maybe we can see a bit more. Yeah, there's something going on here as well. And this was actually activity relating to the icon of mum.doc, changed in 2010. So this will be about the time I did some revisions to that particular image. So you can see there's quite a lot of stuff there. So let's go back and think once again about what it is I'm asking you to look at. So if I bring up the evidence examination sheet, we basically were wanting you to have a look through, have a look at the file, see if you think there's anything suspicious, and work out, document that, and produce a very short report back to the SIO. For example, you found these files, you believe these are the dates in which they're added to the system, and etc. Now, actually, one of the things you can do is check the hash number of the evidence source. So let's think about this in the terms of a security investigation. Okay, so you're working in a company, there's something suspicious about that guy, and you have reasons for believing that perhaps he's engaging in some form of industrial espionage. So one of the things you might want to do is to go over and seize the hard drive from his computer, maybe at night when he's not using it. So it's not his computer, actually, it's the company's computer. Otherwise, you may well find you're actually committing a legal offense. And then taking that, creating a disk copy, and then examine that disk copy at your leisure to see if you can find any evidence of wrongdoing. So that might give you a lot of help in working out what was going on with that particular system and that particular person. So, guys, that's about it from me, and I'm going to now go back to my main video and talk to you a little bit more about what I'm hoping you're going to get up to in this practical. I hope you're going to enjoy it. I hope you'll find it quite interesting, and maybe you will find that you can use tools like autopsy for doing other things in terms of your investigations, because it gives you a good overview of everything stored on a system. You can try it with your own devices, of course. You have to remember the ethical and legal requirements that relate to forensics, that you must not subvert anybody else's privacy. Okay, bye folks.